Hello, welcome back to Civil Engineering Edge. In this video, we take a closer look at a group of Japanese workers using fabric formwork to add a concrete lining to an existing canal leading from a sabo dam. The purpose of this project is to prevent soil erosion and manage water flow in the area, helping protect the surrounding environment. Instead of relying on the traditional rigid formwork method, which would normally take a month to complete, they use fabric formwork, cutting the process down to just 2 days. This method not only speeds up the project, but also reduces labor costs and material use, offering an efficient and sustainable solution for canal construction. Section 1. What is fabric formwork? So, what exactly is fabric formwork? Fabric formwork is a modern construction technique that uses flexible textile molds, typically made from geotextile fabric, instead of traditional rigid materials like wood or steel. These fabric molds are laid and secured along the surface where concrete needs to be poured. When filled, the fabric shapes the concrete into smooth, naturally curved surfaces that perfectly adapt to the underlying terrain. This approach comes with several key advantages. 1. Speed. As seen in the Japanese canal project, a process that would take for weeks using conventional methods is completed in just 2 days using fabric formwork. The fabric is lightweight, easy to install, and doesn't require time-consuming bracing or shuttering. 2. Cost-effectiveness. Fabric formwork reduces the need for heavy construction materials, complex labor, and repetitive equipment. Fewer tools and workers are required, which leads to significant cost savings. 3. Sustainability. This system generates less construction waste, and the fabrics used are often recyclable or reusable. It also causes minimal disruption to the landscape, helping preserve the environment. 4. Enhanced flow and durability. The concrete lining created is not only strong, but also hydraulically efficient. It smoothly guides water, resists sediment buildup, and withstands pressure from high-velocity flows. 5. Design flexibility. Fabric molds allow for custom curves and contours, which are difficult and expensive to achieve with rigid formwork. This flexibility is also valued in architectural and sculptural applications. In summary, fabric formwork represents a smarter, faster, and greener way to construct durable concrete surfaces, especially in water-related infrastructure. Section 2. Where is it used in civil engineering? Now that we understand how it works, let's explore where fabric formwork is especially useful in civil engineering. 1. Hydraulic structures. The most common use is in canals, channels, and spillways. In such environments, managing water efficiently and preventing erosion is crucial. Fabric formwork creates smooth linings that reduce turbulence and protect against long-term wear. 2. Soil stabilization and retaining structures. It's also ideal for slope protection and retaining walls. The flexible mold adapts to steep or uneven ground, helping to stabilize embankments and reduce the risk of landslides or soil washout. 3. Foundations and footings. In construction of buildings and bridges, fabric formwork is used to cast custom-shaped footings or column bases. The resulting shapes often use less concrete while maintaining strength. 4. Architectural design. In modern architecture, fabric formwork is used to create artistic concrete walls, facades, and furniture. The fabric allows concrete to form organic, curved shapes, giving structures a distinctive aesthetic. 5. Remote and emergency sites. In areas where transporting heavy formwork is difficult, such as mountain regions, flood zones, or emergency relief operations, fabric formwork is a game changer. It's portable, foldable, and quick to deploy. 6. Green building projects. With its ability to reduce carbon footprint, use less raw material, and generate less waste, it aligns perfectly with the goals of sustainable construction. So, whether it's a canal, a hillside, or a modern building facade, fabric formwork proves useful across many sectors of civil engineering. Section 3. How is it used in canal lining? Let's now take a deeper look at how fabric formwork is actually used in canal lining projects from start to finish. Step 1. Site preparation. The canal bed is first cleared of debris, vegetation, and soft soil. If required, grading or shaping is done to create the correct slope and channel profile. Step 2. Laying the fabric. Next, custom-sized geotextile sheets are rolled out along the canal. These fabrics are cut based on the width and depth of the channel. The sheets are then anchored securely along both sides using steel rods, pins, or edge trenches. This anchoring ensures that the fabric stays in place and doesn't shift during the pour. Step 3. Placing the concrete. Concrete is then pumped or poured into the fabric mold. As it fills the cavity, the fabric flexes slightly under the pressure, forming a smooth, naturally curved surface. The concrete pushes out trapped air, resulting in fewer voids and a denser, stronger finish. Step 4. Adjustments and finishing. Workers make minor adjustments to the fabric to ensure uniform thickness. In some cases, light vibration is applied to settle the concrete properly. Step 5. Curing and setting. The concrete is allowed to cure inside the fabric usually for 24 to 48 hours. The formwork can either be left in place permanently or removed once the concrete hardens, depending on the project. The final result is a durable, erosion-resistant lining that improves water flow and reduces future maintenance. This system is especially effective in irregular terrain, where traditional rigid forms would require significant reshaping. Section 4. Conclusion and key benefits. To conclude, fabric formwork is one of the most promising innovations in civil engineering today, combining efficiency, adaptability, and sustainability. Let's quickly summarize the main benefits, especially when used in canal lining. 1. Faster construction time. Reduces a project timeline from weeks to days. Ideal for urgent projects or seasonal weather windows. 2. Cost savings. Minimizes the use of timber, steel, and manpower, leading to significant budget reductions. 3. Terrain friendly. Easily conforms to uneven or sloped surfaces, eliminating the need for heavy excavation or earth reshaping. 4. Stronger concrete. The shape of the fabric helps remove air pockets and improves compaction, producing denser, longer-lasting concrete. 5. Low environmental impact. Less material, less waste, and reusable fabric options make this a green construction method. 6. Versatile applications. From rural canals to urban infrastructure and even artistic structures, fabric formwork is a multi-purpose tool. In a world that demands faster, smarter, and greener construction, fabric formwork is not just a solution, it's a forward-thinking strategy that every civil engineer should know about. Thanks for watching. If you found this method insightful and want to explore more innovative techniques in construction, don't forget to like, share, and subscribe to Civil Engineering Edge. Stay tuned for more videos that bridge tradition with technology.